So now class, let us apply what we have learned from the law of sines and cosines in some word problems. So let us see where this law of sines and cosines can be applied. So remember that we can only use law of sines in these cases. So if two angles and a side are known, if two sides and an angle opposite one of them are known. And we use law of cosines if two sides and the included angle are given, or if three sides are given. So let us have this example. A pole tilts toward the sun at 9-degree angle from vertical and it casts a 20-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 40 degrees. How tall is the pole? So again, it is very important for us to understand the problem and be able to illustrate what the problem says. So let us first illustrate. So here's the illustration. So a pole tilts toward the sun at 9-degree angle from vertical. So this is the vertical and this is the pole having a 9-degree angle from this vertical line. And it casts a 20-foot shadow. So this is the shadow. The angle of elevation from the tip of the shadow to the top of the pole is 40. So if this is the tip of the shadow to the top of the pole, so this angle is 40 degrees. So how tall is the pole? So what we are looking for here is the height of the pole. So we are just going to focus on this triangle. But how can we find the height of this pole if the given is just the angle and a side adjacent to it and the other angle from the other triangle? We cannot just instantly apply law of sines or cosines here because there is no case where we can apply law of sines or law of cosine. So what we have to do now is to find other dimension of a triangle. It can be an angle or a side. And because in this figure it is more likely to find first another angle, so let us find the other angles of this triangle. So we know that this angle is a right angle. So if this is a right angle, this is 90 degrees. Therefore, this whole angle is 99 degrees. So if this is 90 degrees and this is 40 degrees, then what would be the measurement of this angle? So we know that this is a triangle. So the measurement of the interior angles of this triangle is equal to 180 degrees. Therefore, our angle in C is equal to 180 degrees minus A minus B. So that is 180 degrees minus 40 degrees minus 99 degrees, and that is equal to 41 degrees. So this angle measures 41 degrees. So since the conditions in the law of sines were already satisfied because we already have three angles here, and in the law of sines, if two angles and a side are known, it is already possible to know the other side. So since we are looking for the side A, and in law of sines we have the equality A sine our A, that is 40 degrees, is equal to, let us take this angle and this side because they are opposite. So that's C over sine 41 degrees. So cross multiply, that is A sine 41 degrees is equal to C sine 40 degrees. So since we are looking for A, we will divide this by sine 41 degrees. So sine. Our A is equal to C sine 40 degrees over sine 41 degrees. So side A is equal to, since our given in our side C is 20 feet, that is 20 sine 40 degrees over sine 41 degrees, which yields 19.6. Don't forget our units, that is in feet. So this is now the height of our side A or our pole. Let us have this another example. So a plane, of course, that is from the top is 1 kilometer from one landmark and 2 kilometers from another. From the plane's point of view, the land between them subtends an angle of 45 degrees. How far apart are the landmarks? So for example, this is the plane. And these are the two landmarks. And says there, a plane is 1 kilometer from one landmark. So let's say this is landmark A and this is landmark B. So this is 1 kilometer and 2 kilometers from another. So this is 2 kilometers. So let's name the plane C. Say BC. So from the plane's point of view, the land between them subtends an angle of 45 degrees. So how far apart are the landmarks? So in this case, we are going to use the law of cosines, since the given here are the two sides and the included angle. So since this is angle C, so this is side C is missing, and this is A, so this is side A, so this is side B. So in getting the side of a triangle using the law of cosine, so we have C. If we can still remember our formula in getting each side, so that is C squared is equal to A squared plus B squared minus 2AB cosine C, since we have C. So C squared, that is equal to our A, is 2 squared plus 1 squared minus 2 times 2 times 1 cosine 45 degrees. So C squared is equal to 4 plus 1 minus 4 cosine 45 degrees. So C squared is equal to 5 minus 2 square root of 2. So since we're looking for C, so let's take their square root. So C is equal to 1.47 kilometers. So the distance of the two landmarks is 1.47 kilometers. Suppose we want to know the other two angles or the measurements of our other two angles in the triangle, then we can also try looking for it using the measurements of the three sides. So if you could still remember, let's say we will find angle A. Try to find angle A. So that is cosine A is equal to B squared plus C squared minus A squared all over 2BC. So we will use this formula to find the measurement of angle A. And that is equal to our B squared. This is our B. That is 1 squared plus our C squared. So that is 1.47 squared minus our A. That is 2 all over squared. Sorry. all over 2 times our B times our C. So cosine A is equal to 1 squared plus 1.47 squared minus 2 squared all over 2 times 1 times 1.47. So that is equal to negative 0.285. So let's get the cosine of negative 0.285. So that is shift cosine negative 0.285. So that is equal to 106 degrees. So this is our cosine A, and our angle A is equal to 106. Let's press the degrees and 33 minutes. So this is 106 degrees and 33 minutes. Next, our angle B. So to find angle B, let's just subtract angles A and C from 180 degrees. So B is equal to 180 degrees minus 106 degrees. 33 minutes minus 45 degrees. So we know that in 1 degree we have 60 minutes. So that is 180 degrees minus 106 degrees, 33 minutes minus 45 degrees. So we have 28 degrees and 27 minutes. So that is now the angle of elevation from this point to the plane. So class, it's your turn. Answer the following problems. Number 1. From a window, Mary sees 2 objects, an automobile and a Nara tree. The angles of depression of the car is 50 degrees, while that of foot of the tree is 30 degrees. So if the distance between the car and the tree is 100 meters, find the distance of Mary to the foot of the tree. So you can use vertical line here to form right angle in order to find some other angles, so that you can use either law of sines or cosines. And the second one, a ship travels 60 miles due east, then adjusts its course 15 degrees northward. After traveling 80 miles in that direction, how far is the ship from its point of departure? So here you can also draw the directions north, south, east, and west to locate the ship. Attach your file in your Edmodo account after finishing your task. Thank you for listening.